Hi girls, I'm going to go ahead and record a video for you on number 22 from the AP test prep section. So this one says a car is sliding down a hill with a slope of 20 degrees. So first I'm going to draw our 20-degree angle. And we've got a car on here. The mass of the car is 965 kilograms. And there's a cable pulling the car up with a force of, so I'm going to call this the force of the cable, and that equals 4,215 newtons. And what is the car's acceleration? So the other forces on the car, we have the normal force, which is our support force, so that's perpendicular to our surface, right? And then we have the force of gravity, which is pulling straight down. And that's going to be mass times the acceleration due to gravity. Okay, so for this problem, it's asking us what the car's acceleration is. So what we need to do here is we need to look at, we're not concerned about the y direction here because the acceleration is going to be along this axis. So one tip actually that I want to mention first is that when you're dealing with problems like this, I want you to tilt the axis to be so that the x-axis is perpendicular to parallel to the surface. The reason for that is because now our force of the cable is here and our normal force is here, so we have two of them on the axes. That means when we're looking at our components of this, instead of having to look at a piece of this, a piece of this, and a piece of this, all we're looking at as we look at this direction is the force of the cable and a piece of the force of gravity. So really, really simplifies what we're dealing with here, okay? So now we need to find the sum of the forces in the x direction, okay? So first we need to look at this little angle here. So we want to find this piece of it. And so cosine is what's going to get us there because it's opposite, and this angle is 20 degrees. So we're going to go the force in the x direction is the force of gravity times, what did I say? This is opposite. So sine of 20 degrees. And this is, so we're looking at, actually we know that this is the positive direction, right? Because it's slipping down. Defining our directions is really important. So we'll keep this positive and we'll make this one negative, minus the force of the cable. And that's going to be our net force in the x direction. So that is going to give us, it'd be helpful if I had a calculator right here. Um, 20 sine times the force of gravity, which is going to be our mass, which is 965 times 9.8, minus, so I'm just going to write 34 newtons, minus the force of the cable, which is 4,215 newtons. And that gives us 981 newtons. And my answer is negative, which means that it's actually moving up. So this is actually bigger. So it's moving up with a force of 981 newtons up the ramp. So that makes me want to change my positive direction, actually. I'll leave it alone, just because I've already gone this far. I just must have, I think that what they mean to say is a car was sliding down a hill with a slope. because now the car is being pulled up the slope. I missed that part. Okay, so that's why I got a negative answer. So our negative direction is this way, so it's going up the slope now, which that's okay. That was what it was supposed to be. Then we know that net force is mass times acceleration. We're only dealing with the x direction here. So now we need to find the acceleration, so we can say that A in the x direction equals the net force, the sum of the forces in the x direction divided by the mass. So we've got 981 divided by 965. And so our acceleration in the x direction is 1.02 meters per second squared. And so that is the acceleration. The car is accelerating up the ramp, right? Because that was my negative direction, even though it probably shouldn't have been, now that I read the question more carefully, up the ramp. Okay? I hope this is helpful. Thank you.